All right, in this example, I'm covering the sum of products. That's what SOP stands for, sum of products, form of converting from a truth table to a Boolean function. And then we're going to go over the security alarm example that was in the practice problems that I posted up on Canvas. So you should take a look at that and understand it. All right, so we talked about this a little bit in class. We want to have the sum of products expression for f. Okay, and so to get there, let's take a look at various places where f is equal to 1. So we see f is equal to 1 on this row, and this row of the truth table. So now to get the sum of products, you need to form the product terms. Okay, so it looks like because there's 3 rows, there'll be 3 product terms. Okay, and from there, we just OR these together to get f. So the last thing we need to do is take care of the inputs to the product terms. Okay, so looking at the first row that's highlighted, all right, so this row, to form the 0, I need an A bar. Okay, so we're going to put A in here, and then put it to an inverter and take it to that gate. Okay, so that takes care of that A bar. Now I need B and C bar. I didn't make this big enough. So here's C bar coming out of that gate, A bar here. Okay, so that takes care of the first highlighted row. Now I need to do the same thing on the other rows. All right, so I've already formed A bar, and so technically, I can get by with fewer gates if I tap off of the A bar that I've already formed. Okay, and put that here. And then I have B and C coming in. So A bar, B, C for this second highlighted row. All right. Then on the last one, I need A. So here's A. Then I'm going to need A bar, B bar. I don't have B bar already formed, so I need to form that. So here's B. This would be B bar. Okay, things are really tight in here, so let me just erase that. Okay, and then the last term I need is C. Okay, so there's a circuit that implements the Boolean function f. All right, now I want to take a similar approach to solve essentially a word problem. Okay, and so in this word problem, we have sensors. All right, so if a window is open, all right, that's going to make the W sensor be a 1. Okay, if a door is open, the D sensor would go to a 1. All right, if the alarm is activated or set, you get a, you have a low. That happens. You might be asking why would it be a low instead of a high. You can assign it either way. So in this particular problem, if the alarm is activated, the switch indicating that would be a low voltage. All right, so this is all part of the given. All right, so what I want to do in the first part, it says build a truth table to send an alarm, so the output is going to be F, and that's going to indicate that we send an alarm if a window or door is open, but only if the alarm is set. Okay, so we can make a truth table And honestly, it doesn't matter the order of the variables. Okay, I'm going to do it differently than what the solutions that I gave you to this problem were, just to show you can do different orders. Okay, so I'm going to put window first, door second, and the switch last. Okay, now there's 3 variables here, so there would be 8 combinations of inputs. So we could write those down. Now it's easy to take this row at a time, okay, and figure out what the output F should be. So W equals 0, D equals 0, it means everything is closed up and the system is activated. So there's no problem here. We don't want to set the alarm, so this would be a 0. Okay, again, 0, 0, nothing's open. And in fact, we don't have the alarm even set, so that would be a 0. Okay. In this next row, a door is open and the system is set, so we need to set an alarm here. All right. The next row, a door is open, but the system is not set, so we don't send an alarm. Okay. And then this next row, a window is open and the system is set, so we need to send an alarm. The next row, the system is not set, so no alarm. Okay, the next row, we have both a door open and a window open and the system is set, so we send an alarm. And in the last case, the system is not set, so we get no alarm. Okay, so you see there's 3 product terms here. All right, and so I can make those 3 product terms. I'm going to space these a little further out this time. Okay, or those together and get F. All right. So what I worry about is the places where I have a 1 for F. So right here, here, and here. All right, so taking the first highlighted row, I would need W bar. So I'd take W and invert it to get W bar. I need D, because D is equal to 1. So take care of that. And then I need S equals 0. All right, so let's make an inverter. Actually, we don't need to form. Yeah, we do. That's right. So here's S. Okay. All right. Next, the next row, we took care of all these. Next, I need W, because W is a 1. And then I need D bar, S bar. All right, so I don't have W bar. And I need S bar, which I already have up here. So I can tap that off and come down and put that here. All right. And then the last case that I need a W, D, and S bar. Again, I've got S bar already. And I need to put in the W and the D. All right, so here we go. This is our sum of products circuit for the alarm. Okay, I also wanted to show you that you could take this Boolean expression, and by the way, I could write this out as a Boolean expression. Let's go ahead and do that. F is equal to W bar D S bar or W D bar S bar or W D S bar. Okay, so that's the Boolean, the sum of products Boolean expression for the alarm. Okay, the next thing I want to show you real quick in this little video is there's another form of this. You can do what we call Boolean Algebra. We haven't talked about that in class, but there's a way to get to a simpler circuit. And sometimes you can just see it. Like in this case, I think this is fairly obvious that this is the logic that we're using. If we have either a W or a D and the system is set, we would send the alarm. Okay, so this would also be a circuit, and it's probably a little more intuitive that this is what it would be. All right, but I would just want to show you can go from a truth table to a circuit to implement any given problem that you have. All right, so you could check this. You could make your own truth table, SWD, and put in all the combinations and verify that this gives you the same exact functionality as the original truth table.